is hypothesized to have begun as a gaseous world with a rocky core. Starting out at several times the diameter of Earth, this so-called sub-Neptune quickly lost its early hydrogen and helium atmosphere due to the intense radiation of the young hot star it orbits. Then, the planet was stripped down to a bare core about the size of Earth, and that's when things got interesting. To the surprise of astronomers, Hubble observed an atmosphere which, according to their theory, is a secondary atmosphere that is present now. Based on a combination of direct observational evidence and inference through computer modeling, the team reports that the atmosphere consists of molecular hydrogen, hydrogen cyanide, and methane, and also contains an aerosol haze. Scientists think hydrogen from the original atmosphere was absorbed into the planet's molten magma mantle, then slowly released through volcanic processes to form a new atmosphere. Though this hydrogen continues to escape into space, the secondary atmosphere is replenished by volcanic gases that seep through cracks in the planet's thin crust. Scientists are wondering how many other planets might have started out as gas giants but became smaller and rocky after their early atmospheres evaporated away. Astronomers hope to use the upcoming James Webb Space Telescope's infrared vision to detect hot areas of volcanic activity on the planet. GJ 1132b might be orbiting a distant star 41 light-years away, but thanks to the Hubble Space Telescope, it just got a little bit closer.
Moon. Now, the data from Hubble is in and processed. Have scientists found our first exomoon? Looks like they still need more observations to be 100% sure. The moons in our solar system are very diverse, some with liquid water, some that are potentially habitable, so being able to observe moons in different solar systems would give us a whole new treasure trove of interesting worlds to study. The team of astronomers from Columbia University sifted through data from 284 Kepler measurements of transiting exoplanets. A transit happens when a planet passes directly between us and its star and blocks out a small portion of the star's light, which produces a dip in the amount of light coming from that star over time, called a light curve. If there's a moon on either side of the planet, we might be able to see a second, smaller dip in the light curve. Making transit measurements and processing the data into a light curve can be very tricky though, so scientists need to observe multiple transits in order to get convincing evidence of an exoplanet or an exomoon. Out of the 284 planets the team looked at, they found one planet with an extra wobble in its light curve that might be a moon. This planet, Kepler 1625b, orbits its star once every 9.5 months, so it takes years to observe multiple transits. The team only had Kepler data from 3 transits of this exoplanet, so they sent a proposal to the Hubble Space Telescope to capture more data of this possible exomoon. Hubble can measure light curves much more precisely than Kepler, so Hubble can more definitively confirm or disprove the existence of this exomoon once it gets multiple transits. So far, the team of astronomers has collected Hubble observations of one transit of exoplanet Kepler 1625b. Hubble measured the light coming from the star over a period of 40 hours. About 7 hours into the observation, the planet started its transit, which was about an hour earlier than predicted. A tantalizing piece of evidence that the planet has a large moon, because a moon would cause the planet to wobble in its orbit. The planet transited across the face of its star for 19 hours, as expected. Then, about 3.5 hours later, a second, smaller dip in the light curve started. That right there is intriguing evidence of an exomoon. The Hubble observation unfortunately concluded before the possible moon finished its transit, so Hubble hasn't yet observed a full transit. This light curve appears like it shows an exomoon, but we can't say it's a definitive detection until Hubble observes at least one more transit. If this is actually a moon, what do we know about it? The planet Kepler 1625b is likely several times the mass of Jupiter. Its possible moon appears to be about the mass and radius of Neptune. The ratio between the mass of this planet and its moon is about the same as between the Earth and our moon, but scaled way up. Neptune-sized moons are obviously not something that exists in our own solar system, and we're not sure exactly how such a moon would form. When scientists first started discovering exoplanets, a lot of them were several times the mass of Jupiter because big planets are easier to detect. So a similar thing may happen when discovering the first exomoons. Finding planets and moons so different from the ones in our own solar system gives us a lot more knowledge of the many diverse ways planetary systems can exist. In the near future, scientists hope to use the Hubble Space Telescope to try to confirm the discovery of this exomoon. And then they'll use Hubble for follow-up observations of other planetary systems discovered by observatories like Kepler and the recently launched Transiting Exoplanet Survey Satellite, TESS. And then the upcoming James Webb Space Telescope will be able to take high-precision measurements in infrared wavelengths, which combined with Hubble will allow for detailed characterizations of a whole bunch of really interesting exoplanets and likely exomoons. So, if you like planets, and honestly, who doesn't? Stay tuned to learn about all sorts of fascinating new worlds.
We'll talk all about that on this episode of Crazy Engineering. The Hubble telescope is composed of several different instruments, and outside of those is something called the primary mirror, where all the light bounces off of and goes into the instruments. That's where the flaw was. So the problem was something called a spherical aberration. What exactly does that mean?
It means the primary mirror had the wrong shape. That is, it's a shallow bowl, effectively, that brings light to a focus. It's a little too shallow. It rendered the telescope fundamentally unfocusable.
So it was a little bit out of tolerance on that primary mirror, and it was affecting all the instruments in the Hubble?
All 5 scientific instruments on the Hubble depend on a sharp image. That's the whole point.
So Hubble's sitting in the doctor's chair, and it has the eye chart in front of it, and instead of seeing the letter E, it sees the letter F.
Worse, what it sees looks like a squashed spider.
But it's way up in space and you can't get it back here, so how do you fix it?
Well, if you're born with eyeballs that don't quite work, you don't go and buy new eyeballs, you buy a pair of glasses, and that's the approach that we took.
The wide field and planetary camera, known as WIFPIC, relied on light from the primary mirror.
The light from that primary mirror all comes down to a focus inside our camera on a mirror that looks just like this. And this is now an opportunity for us to correct the curvature, the shape of the primary mirror right here. We simply put the same error in, reversed, and corrected. The Hubble telescope was designed from the outset to be serviced every 3 years by astronauts.
Andrews, you can take it away.
The camera is designed to be replaced in space. That's the one thing that was really just waiting for us to take advantage of.
Looks like it's in there. Yeah, mine's beautiful. Okay.
So what was the outcome?
At the Space Telescope Science Institute, way down in the basement, there were a bunch of us watching. And the first image, which was of a star, looked good. So we knew right away that we had a fix. And everything that Hubble was supposed to do was now going to happen.
So I think I speak for everyone when I just say thanks to you and your team for all the hard work you put in fixing Hubble, because now we have these images really forever that we can appreciate. WIFPIC 2 went on to become the workhorse for the Hubble telescope, and it lasted for more than 15 years. Well, now you guys can check it out at the National Air and Space Museum in Washington, D.C., and we'll see all of you on another episode of Crazy Engineering.